Hello, everyone. My name is Chris Burns. I'm a senior ML specialist at AWS, and I'm also the lead developer on the AWS-JPL Opensource Rover Challenge. This is the first video in what I hope is going to be a series of videos to help the participants get started with the challenge. This first video is going to be an overview of the challenge, how to get started with Robo Maker. I'm going to answer some questions that I've seen trickling in on the Slack channel. And then future videos, there'll be 3 of them. I'm going to dive deep on the Rover node. So that's a node. When you hear node, it's a ROS, the robot operating system phrase. I'm going to dive deep on the Mars world with the Gazebo simulator. And I'm going to dive deep on the RL agent. Now, before I get started with this overview video, a couple of housekeeping items I wanted to take care of, primarily based on questions that I'm seeing in the Slack. And I guess we'll get the bad news out of the way first. So this is a challenge. It's not a tutorial. So we're going to expect you to put a little bit of work into this. And while we're here to help you with technical questions, we are not going to answer questions about reinforcement learning. That's the aspect that you're going to bring to the table. We're hoping that you're going to do some learning on this journey. Now, you don't need to be an expert in deep learning. You don't need to be an expert in reinforcement learning or deep reinforcement learning. You'll see from the examples that we provide and the code that we provide, you can do some basics and still complete this challenge. Now, because this is a challenge, we've simplified it in some aspects. We've made it difficult in other aspects. So many will enter this, but few will submit working projects. And so unfortunately, AWS credits are not offered to participants in order to compete in this challenge. There are some free tiers that you can use along the way. I'll highlight those as I create more and more videos here, especially with Robo Maker. We're going to see that just today, where you get 25 hours of simulation units for the free that first month. That will go a long way towards your first submission to the challenge. And then any more details you need about registrations are at spacechallenge.tech. So with that, I'm going to move on to a couple of other, I guess we'll call dependencies, if you will. So the first, I saw a question about somebody had an i7 set up and they wanted to know if they could run the challenge locally. You can absolutely build your assets locally. This is going to be a scenario where you build a little bit locally, fast iteration, and then you're going to move to the cloud for training, simply because these local workstations probably aren't robust enough for the training aspect. And the machine that I'm using here, as you can see, is an Ubuntu 18.04. Now, I'm showing you these versions because I want you to use the same versions that we use when it comes to these packages. Gazebo, ROS, Python, it needs to be the same versions we're using. If you ask us a question for help, the first thing we're going to ask is what versions you're using, and if they're different, it's going to be very, very difficult for us to provide assistance when you're using different versions. As far as CPU goes, this was built primarily on an i7, as well as some cloud services. And then finally, if you want to do a little bit of training locally, we use RL Coach and we use TensorFlow, so we can use GPU, and that's hard to see. You see here I have an RTX, so it's a 2080 Ti, but nothing extravagant to use these. So we're making some assumptions with this challenge. We're going to make some assumptions that you have some familiarity with Python 3, that you have some familiarity with compiling code, that you have some familiarity with AWS core services like S3 and IAM, so nothing out exotic there. And you're going to need to build up some familiarity with ROS. If you don't have any ROS experience, you don't need to be an expert. You don't need expertise. You just need a basic understanding of how the ROS nodes work and how messages are being passed into the simulator. That's going to help you build your reward function in the RL code. So you see here, I already have a ROS core running, but I'm using Melodic 1.14.3. Don't use Kinetic, and don't use ROS 2. And then when it comes to Gazebo, I have the Martian world running right now. So we'll pull this up. So this is the Martian world. This is about 250 meters by 250 meters. The challenge is localized. I've made the environment larger to build out future challenges. Now this is all running on that i7. So I saw a comment from somebody that they didn't think their local workstation was powerful enough to run the simulation. That's not correct. It absolutely is. I'm going to zoom in. Here is our rover, patiently waiting for instructions. You see this this play icon here. This simulation is paused. That's why my real-time factor is 0. Time is not moving. And the essence of the challenge is to get your rover from this starting location, which is at 0, 0, to right about here near this red crater. The way the scoring mechanism works is you start with 10,000 points upon completion. When your rover reaches this destination, you have 10,000 points. And then I'm going to subtract time steps. Time steps is not a physical movement. Time steps is a reinforcement learning phrase. A time step is a tuple, if you will, or a combination of making an observation, taking an action, and returning a reward. Now we're subtracting your time steps because we want to incentivize you to complete the challenge in as few time steps as possible. The next measurement that will be deducted from that 10,000 points is the distance traveled. If your rover, we want to incentivize the rover to take the shortest distance possible. And then the final metric that will be deducted from that 10,000 points is basically what we call jerk or acceleration, IMUs. The rover is 6-wheeled. It has IMU sensors on every wheel. And the acceleration, or the jerk, if you will, is basically how bumpy the ride was. And what we're going to do is we're not taking a rolling average there. We're going to take the highest acceleration point of the rover throughout the course, throughout the challenge here, and then we're going to subtract that from the 10,000 points. And we do that so that if you incur jerk or rapid acceleration early on, and then your ride smooths out, we're not going to take an average. We're going to take the maximum. So that's a quick overview of the Martian environment. And now I'm going to move on to Robo Maker. The challenge, participants are going to use a lot of different tools to build their submission, but the submission has to come in the form of a Robo Maker simulation. In the GitHub repo, there's a quick diagram of the 3 major components: the rover, the gazebo world, and the RL agent. I'm not even going to use your rover and gazebo code when you submit it. I'm going to use basically what's called a gold standard. I'm going to have that standing by. That way I know it's not altered. I'm going to just plug in your RL code. So to get started here, we want to create a Robo Maker environment. We want to create a development environment within Robo Maker. It's important that you create it within Robo Maker. I'll show you why in just a moment, but don't go to Cloud9 and create the environment. Now I have an empty environment here called demo that's standing by for us because there's no sense in you watching the environment get created. But I do want you to see these steps because there's a couple of call outs here that I want you to pay attention to. Again, we're going to choose ROS melodic, however you want to pronounce that, and an M4 large. So for those of you that are concerned about price, there's going to be a small price incurred on AWS to complete this challenge. It's just really unavoidable. But I'm going to show you just to put it into perspective for you. I'm using an M4 large for this development environment. And if I go to my pricing here, an M4 large is 10 cents an hour. So if I spent an entire workday, 8, 9, 10 hours within the Cloud9 environment, I will have incurred a charge of $1. So nothing outlandish there. You're not going to incur thousands and thousands of dollars to attempt to win a $15,000 prize. Let's go back to Robo Maker here. Now, here's where I want to make this call out. This is important. I'm going to use this default VPC, and then I'm going to choose a subnet in 1A. Within the Robo Maker JSON settings file that's in the GitHub repo, the references to subnets may already be in there. And you're going to have to make sure that you update those based on the environment that you create. Now, I would hit create here, but I don't need to. I already have this demo environment waiting for us. So I'll go there now. One of the callouts I need to make in the GitHub README is the environment that's in GitHub needs to be in the root of the Cloud9 development environment. Now, I've actually already deleted some default files that were in here. Basically, I came into my environment and I just blew everything away. Now, a note here, if I take a look, there's also this C9, this .c9 folder. We also want to remove that. It will come back, so don't worry about it. I want to make sure this is completely empty, because when I clone my GitHub repo, maybe the longest repo name in the history of repos. I'm going to use this dot notation here. This means I want to clone that repo to this current directory without creating another working directory. This is important because when we come into this settings file, the JSON file here is a collection of commands I've already prepared for you. When you're dealing with ROS nodes, everything is compiled. If you're working locally, you'll probably use a catkin make. In Robo Maker, we use colcon. We use colcon because it provides a bundling feature that I'll explain in just a couple of moments. And so we see here that now that I've basically brought this into the editor, and so, actually, let me change this first. I give you a blank one. Actually, it's got some placeholders in it for what you need to change, and I give you this one as an example. So don't use the Burnska example. You can't use the Burnska example because it's tied to my account and you don't have access to my resources. I'm just going to change this to blank. I'll rename this one. Now I'm going to load this into the editor, which basically sort of sources it. Now I come here to run. So a note about the Cloud9 environment. Because I created this environment from Robo Maker and not from the Cloud9 console, I get these integrated Robo Maker tools. If you go to Cloud9 and create an environment, you're not going to get these integrations. So again, make this development environment from Robo Maker. Now when I go to run, you see I have these commands already available to me. This is what the Robo Maker settings.json file provides for us. So this build all here is a reference to this configuration, build all. And you see here the command is colcon build, and it runs from this directory. This is important. This is why we deleted what was in this demo environment originally and put our GitHub at the root of this environment, because this is path-based. You can bring additional environments in here. You don't have to delete it if you want to bring in the GitHub repo, but what you're going to have to do is you're going to have to come into this settings file and update all these paths. So it's simply easier to delete what's there. Not an ideal scenario, but when you're blasting this out to a wide audience like this, I felt it was the lesser of the evils. Now back to this colcon colcon bundle. This Cloud9 environment is residing on an EC2 instance. That was the M4.large instance that we made. When we create a simulation, we're going to ship this off to a Robo Maker managed service where this is going to be moved to another instance. So what colcon bundle does for us is it takes all these nodes that we compiled and it creates it adds up all the dependencies. Gathers up all the dependencies and puts them into that output.tar file that we'll see here in just a moment. Drops it on S3. Get used to S3 being your substrate. It's the most proficient and efficient form of persistence in the world today. So don't be afraid of S3. And with that, I think we can start to run this. So what I'm going to do is I'm going to demonstrate here a workflow. So a workflow is simply a combination of build, bundle, and simulations that I've put together for you. You can spend some time getting familiar with this JSON file if you wish, but really it's something that'll come to you as you run more and more bundles, as you run more and more builds and simulations. But if I scroll down here to the bottom, we'll see the workflows. And we're going to run Mars environment full simulation. And you see here my configurations is going to build all first, then it's going to bundle all, and then it's going to run this simulation, the Mars environment with RL. I provide a couple of options here. Mars environment without RL. What that's going to do is going to load the rover in the Martian environment without running the RL agent. So if you need to evaluate something without actually kicking off the RL process, that's available for you. I'll spend just a moment here talking about what a simulation configuration is. So we have an ID and a name. The name is what you see here. The ID is usually unique. If you don't populate that, you'll be provided with an alphanumeric character. I like to make those uniform. You see that this is the type of simulation. Simulations are a little bit interesting. When it comes to RL, in their presets file, which we'll see in a subsequent video, there is a duration. How many time steps do I want to iterate before I shut down my training? When it comes to the Robo Maker simulation, there's no goal. There's no feature or service that says, okay, you've achieved your goal, we're going to shut down. You essentially attach a time stamp to it. And in this case, I want it to run at 86,400 seconds, which is, I think, 24 hours. Failure behavior, if you want to leave this on continue, but be mindful that this is going to continue to run for the maximum duration in seconds. What happens if it fails, if you don't have this on continue, then it just exits and you don't have access to the instance anymore. Because I have it set to continue, if my simulation should fail, I have access to that instance and I can go in there and I can debug. IAM role that I have, this came with the Cloud9 environment. You'll find that in the IAM console. This is an S3 bucket. And then I have my subnets. So this is where I told you to be mindful when you're creating this environment. You need to make sure that these match. Even if I were to use my own JSON file here in a new environment, these are probably going to be different. And so here's the simulation app itself. And what I want to do is I'm going to launch the Mars package. We come over here to our source code. This is the Mars package. See, this is a CMake file here, a package. This gets compiled into a node. And that's the node name, Mars. And then within that, I'm going to have launch files. This is Mars full sim launch. I'll get into launch files when we dig into the Gazebo webinar. And then my Markov preset file. It references the preset file. I'll dig into these when we get into the RL webinar. But I don't want to muddy the waters with any more of this today. I want to go ahead and kick this off. I'm going to do the Mars environment full simulation. And when I kick this off, I am going to edit this video a little bit because there's no value in watching code compile, but I'm going to talk for just a few more seconds to give you an idea of what's happening here. What's happening is each one of these nodes within my source directory is right now being compiled. Once they're compiled, I'm going to use bundle to download all dependencies, package that all up into a tar file, ship it to S3, and then we're going to kick off the simulation. So I'm going to pause the recording here while this compiles and bundles. This is about a 60 to 90 second process. And then I'll be back to introduce the simulation panel within the Robo Maker console. All right, building and bundling is done. I'm going to show you here that the build took 1:41 seconds. The bundle doesn't have the time, but it took about 2 or 3 minutes. The first build and bundle are always longer. Subsequent builds will go relatively quickly. And then I left this here on purpose because the warning I gave you, I did not heed myself. When I started off the simulation, I tried to use a security group from the JSON settings file that was associated with a different Cloud9 environment. So you see here that this security group does not exist. You will probably get something similar to this. Super easy to fix. I want to show my dirty laundry here just so you can see how this is fixed. So I'm going to go into Robo Maker development environments. I'm going to find the environment that I'm using, and I'm going to hit edit here, which is really going to allow me to see all the details. And I see that it's using this security group, which is different than my development environment that I used to create this solution. So now I'm going to come back into my environment, do a simple search here for security groups. It appears in 3 different spots. And I'm going to update that. The nice thing about the JSON file is I don't have to rebuild and bundle. I simply just run the simulation from here. Make sure I do save that. And then my guess is we need to look at these subnets as well So go under my environment. Yes, so subnet CCF. Come back in here. Oh, no, okay, so that is correct, CCF. And from here, I come back up and I can I don't need to go to the workflow. I don't need to rebuild and bundle. I can simply launch the simulation, Mars environment with RL. What this is doing is it's copying that output.tar from S3 that our bundle placed in our bucket. And then it should kick off the simulation. All right, simulation job was created. So from here, we can actually leave the Cloud9 environment. See, we got this notice here. And then we can go and look at the simulation details. Now I'm going to reiterate here that the simulation, it doesn't have a specific goal in mind. The concept of a simulation is it runs for a given time period. And we gave it 1 day. That was just kind of an arbitrary choice on my part. I've never let a simulation actually run for an entire day. You may. It would be really up to you. In a subsequent video, I'll do some talk about checkpointing. TensorFlow is going to create checkpoints in every X number of minutes based on a value that you give it in a preset file. I found that once an hour is really sufficient, and then you can graph those checkpoints to check for accuracy. So it takes just a couple of moments for this to spin up. Recall, this is moving the output.tar from our Cloud9 environment to S3, and then spinning up a fresh environment within Robo Maker, bringing down that tar file, deploying that, and preparing to run the simulation. And once this starts up here, what I'm going to do is I'm going to drop into Gazebo, and we should see the rover moving around. I'll try to be quick because, and I'll tell you just a moment and why. Once the rover makes contact with an object, it's going to just stay there. You have to decide on when to end an episode. If you look in the training grounds, the training ground simulator, you'll see that if I make contact with an obstacle, that ends the episode, and I move the rover back to the starting location. But you have to do that yourself. You decide when the episode ends. You decide what the reward score is. All right, so our simulation is running. We're going to connect to Gazebo here. I should have been a little bit quicker so that we could see the rover move before it makes contact. Yeah, and so he already took off. Let's see how far it got. This is probably going to be pretty bad. And there he is. And this looks like it might be, no, it's not. It's not been trained. He just got a little bit fortunate there. Actually, I'm running a full simulation here. So TensorFlow is working behind the scenes. It is going to try to learn to navigate. All right. Went back to the beginning. We hit that rock a little bit too hard. Okay, so that's it for the overview video. Keep the questions coming in Slack. Once again, I need to iterate that this is a challenge, so we're going to try to help you as much as we possibly can. But we can't give you pointers on building this reward function. We can only help you with maybe some coding syntax, some of those things that are technical in nature, and then we're going to get a wiki set up so that when anybody asks a question, we get that question republished to the wiki along with the answer so that everybody can see all the questions that have been asked. Thank you for your time. I really enjoyed building this, and I'm really looking forward to seeing the innovative and the creative solutions that everybody provides.